Avogadro's number, additional facts, part E. Amedeo Avogadro did much more than propose the famous number that carries his name. He also studied gas behavior, chemical bonding, and molecular structure. His ideas helped shape early atomic theory. Avogadro's work connected to scientists like Joseph Gay Lucas, who studied gas volume relationships, and later researchers who expanded molecular chemistry. His contributions laid the groundwork for understanding moles, gas laws, and how particles behave on a microscopic level. These ideas still support modern chemistry, from stoichiometry, I don't know, I'll probably chop that up, but to predicting reactions in labs and industry. Facts I found interesting personally while working on this project. I learned a lot more about Avogadro's number than I expected. I didn't realize how often this constant is used in chemistry and how it connects the tiny particle world to real measurable amounts. I was surprised at how huge the number really is and how it lets scientists count atoms in a practical way. If I had more time and resources, I would look deeper into how Avogadro's number is used in modern nanotechnology and how scientists measure such large quantities with high accuracy. Overall summary. Working on this project went smoothly overall, and it helped me understand Avogadro's number in a clearer way than before. The most important part was realizing how huge the number is and why it matters for real measurements in chemistry. The easiest part was gathering basic facts, explaining why Avogadro's work is still used today. The hardest part was creating a unique numerical problem and making sure it's connected to the topic in a meaningful way. What surprised me the most was how many modern tools and calculations depend on this constant without most people realizing it. For relevant sources, so to the right, I have my picture sources, part B, part C, part D. Specific source I used in the project was from the Britannica, I don't know how to say that, biography. Let's see. The source helped provide accurate background for part B because it explains exactly who Avogadro was and why his work matters. It verified the scientific foundation behind Avogadro's number and gave historical context. I used the source relevant scientists for the relevant scientist slide 1.4 part B. I have other sources listed since I had to split up my sources with my other classmates that are also in this group project. I have 3, and then 4 altogether with the Amedeo Avogadro's specific source used in the project.
Today I will be talking about Avogadro's number. Additional facts about Joseph Loschmidt. He was the first person to estimate the number of molecules in 1 cubic centimeter of gas. This value later became known as Loschmidt constant, closely related to Avogadro's number. Additional interest. Facts that I found interesting. I didn't expect that Loschmidt had drawn diagrams of molecules, including ones like benzene, before the famous chemist Kilke published his ideas. It surprised me how ahead of his time he was. He contributed to multiple fields: chemistry, physics, and thermodynamics. Overall summary. The hardest parts were understanding the deeper physics behind the Loschmidt constant, learning how his work fit into the debates about thermodynamics and era of time. What surprised me during this project was how many different fields Loschmidt influenced: chemistry, physics, thermodynamics, and even statistical mechanicus. Was surprising to learn that someone not widely known today had such a huge impact on how we understand molecules and gases. relevant sources. Gave accurate information on Loschmidt's life, background, and major scientific achievements. Used for basic biography, dates, and main contributions. That is all I have today.
You're going to be presenting part E for Avogadro's number. So, first slide I have additional interest. I have Gene Perrin, so I was surprised that people did not believe atoms were real before Perrin's work. I thought I would learn only about atoms, but I also learned about the Brownian motion and how experiments prove theories. I learned that Perrin helped support Einstein's idea, not just his own work. If I had more time, I would study more about the Brownian motion experiments and how Perrin measured Avogadro's number. Next, I have the overall summary. The overall summary for Gene Perry, the most important part was learning how Perrin proved atoms exist using experiments. The easiest part of the project was finding basic facts like his discoveries and the words. The hardest part was understanding Brownian motion and how it proves atomic theory. The most surprising part was learning that scientists did not always believe in atoms, and Perrin's work helped settle the argument. And for relevant sources, here's where I got my sources from. I got the biography page on Nobel Prize websites, the Britannic article of Gene Perrin, and the article of Linda Hall Library. This one, there's another one. Additional facts. Gene Perrin proved atoms were real, which people doubted before. Studied Brownian motion. Used experiments to help find the Avogadro's number. Won the 1926 Nobel Prize in Physics. Worked on ideas about matter and energy. Helped prove scientific research.